The hermetic oscillator is it's an acronym. It's a chicken farm, and well, how do I want to explain this? It's an oscillating hermetic operator because certain parts are adjustable at B and certain parts are not. They're determined by the normalization. It's a chicken farm. Matter of fact, it's an egg processing plant. And the reason that's important to remember is because E equals mc squared. It's a form that you're going to remember as far as a wave function trial of variational principle theory, which is a variant theory, divergent. All right, so the hermetic oscillator is me. Let's say I'm a time independent hermetic operator. What does that make me? That's a fast hand exotic for an abbreviation on Bones. Let's just cut to the bullshit. Bones had come to your chicken processing plant and wants to know about your egg count because eggs are energy. And energy is going to correlate to my egg salad sandwich and omelet for breakfast in my IMA indentured servitude program for 90 days. We'll see what you can do on that. That's a hard line. If you're down for it, you stay. If you're not, you don't. And that's again this determined by normalization that in a trial run we determined an energy by gauge space, or that it was the energy by a gravitational space or a gauge space. Inside here because it's an exotic aneurysm acronym of this trial run. Remember, this is a hermetic oscillator, so it's Bones. Well, here it's a time. It's not. It doesn't necessarily say time independent, but it's a one-dimensional hermetic operator, so it's any kind of point. And that's a bit of a Klein bottle of all points that are going to say, well, I'm going to do this, and I'm going to bring it to a wave function. And nowhere's in here was t integrated. It gave me a measure that I have to then equate to that line, and in that line add a high and low. So again, the egg processing plant. There are going to be things like, what do we do with all the chicken? We just can't. We sell the chicken, right? Well, composting is also an option. Is that going to fit the better narrative of the trial, or is that going to be something that's only an adjustable parameter? Again, when we define it as an eggplant and we have all that extra compost from the chicken that we had, or we go about making Rhode Island red rooster chicken dinners around there, well, then that would be the idea. So it's really important as a perturbation theory or a variant in your system when you do understand this math. Again, some people are gonna read it real like I do, a little bit of the tea leaves, and some people are just not gonna understand for poly. And don't feel too bad. Remember, this is C++. It's more important that I understand that you're not understanding the chicken farm because you think that this is quantum mechanics instead of the vice versa. You do the quantum mechanics and now you have to convert over to what this is, because even though you're greater in some manner as far as what it is, it's still not pulling it down like a chicken farm, is it? So you're going to have to correlate this with that mosaic in the stone mill, the compost aspects of this, or in the some fact that somebody had a chicken farm with all those eggs out there and never modeled to do sales of chicken breast. Now, with that said, there are variations. It does matter. If it's not the breed type that we want, we're going to have a big problem here on this Typhon eggshell here. And that's a really important, very important notation to have this. So again, when you're me, I'm not about to get into here and tell you some nonsense that all fourth graders know this, right? This is what this. They do, but by different numbers. You got to start this way simpler off of what this is to create that egg, that EGS. And inside here, they have to understand that T is going to be in brackets, is going to be that wave function set at any new point inside here. Here we're following the process of analyzing brackets A, and as we go through that, we're going to start to organize our first trial set. and that's going to tell me brackets on this side, brackets on this side. This telephone pole right here is essentially this whole operation. I put a board in, I do an operation, I take the board out, and I put it in a pile, which is still not the whole operation. As you read this out, this just equals the next step. Now that it's in that, I put it on the pallet, I put the number of them on the pallet, because it could be eggs or board, and I band and wrap up that pallet. But that's still not the end of the job, but they are equal to that telephone pole. Here, I got to get chickens, I got to get board, I got to do shit with that board or stone or whatever else, and then I have to process it and send it. And at some point in time, somebody's going to put that into some swimming pool. They're going to eat it for breakfast. They're going to do whatever in that X, Y, and Z adjustable 2-pi notation, where I'm saying out of the day. We're not saying that that's just one half of it. We're just saying right now, the radial that you're running is breakfast with the eggs. And that's your general squared route, or at least cubed X, Y, and Z, because that's over pi. And pi is going to come up to the square root of -1 at some point in time, not directly, and I'm probably sure the math's around here somewhere, but that's the notation that in your breakfast run with the eggs, while doing variable principal theory, that anything that goes against that A model is potentially an adjustable state, or is something that is quantified as a -1. It interfered with your breakfast. It kept it from being that at least straight line or better, because if you were up here, then -1 is arguably an operating phase of the moments you just had. It's not until you're up 2 or 3 at that first initial system, the eggs are starting to hit the crates, everything's looking good, that you get into this variable or variational. The day was different. The orders were different. Some kind of big sales on what type of headstones we're selling. Whatever it is.